Now that we have some information, we have a meter in place, we have information, now we have to start looking at how are we going to interpret that information. Because this is going to generate tons and tons of data. What are you going to do with it is now becomes more important. Why do we even measure stuff? Right? One of the reasons is to advertise our credibility. We said we're going to save this much money. We're saving this much money. So that's one reason why we would want to measure it. But more important is, you know, we can predict the future. How cool is that? How many times can you say, I know what's going to happen ahead of time? Measurement allows you to say that with a high degree of certainty. So if you want to do some improvement opportunity in the future, you can identify it and you can assign some expected numbers to it. And that will allow you to allocate your resources to something that actually pays back rather than guessing blindly and randomly. But mostly what it comes down to, unfortunately, in our industrial environment, it's about good old boring improving the productivity stuff. Tighter cost controls, better preventative maintenance, increased uptime, more capacity, and ultimately improved quality. All of those, tighter cost control, I don't have to explain to you. If you can know for your product mix how much each of those products actually uses in energy, you can price it better rather than just saying, I have this much cost over the month, I make these many widgets, I just divide them up. Better preventative maintenance. If you have a system that tracks the gas usage or electricity usage or water usage and all of a sudden starts climbing out of your expected range, it's time to clean that heat exchanger. You don't have to wait until something blows up and you have downtime that you didn't expect. Increased uptime, a result of those two together. More capacity. Now you don't have to do unexpected downtime, so you have more capacity. You can make more widgets within the same time frame. And improve quality. I used to work in a facility where we had 12 annealing and high heat furnaces for steel. And I can tell you that I didn't care how much energy I used. It didn't matter to me as long as I made the product. But I did care if my set point started to drift of 900 and something degrees Celsius. I wanted to know that. Well, drift in the set point temperature equals drift in energy used. So if you can measure one of those, you will get a better control. You will have a tighter control. Look, some examples. These are very simple examples. I just put the months. I usually look at the 3-year history, cubic meters per month, and the outdoor temperature to start with, just to give us an idea what data, how data can be interpreted in a very simple way. So if I just take month and natural gas consumption, I get something like this. Okay. So now I know how much gas I used over the last 3 years. I know when it peaks, and if I'm really looking at it, I can say that it peaks in the winter time, it goes down in the summertime, it's all good. Nothing special. But now I have the record of it. Much better piece of information then is this kind of information. I take the same data, I averaged over 3 years, and whatever I get in the summer usage is my process. It means it's being used no matter what the temperature outside is, which means that's my process-related usage. So that's the red one. The leftover for each individual month on top of it in blue is then seasonal usage. It means it's affected by the outdoor temperature. Mind you that usually it's space heating and ventilation, but it can be process-related as well. But it's seasonally driven. It's driven by change in outdoor temperature. So this is a much better way of looking at the data than just 3-year consumption. So what is that teaching us is that we have to put energy consumption into perspective and into context. Energy consumption on its own won't do anything for us. You have to put it in a context of outdoor temperature, your production levels. What is it that explains that energy usage? Or are you just using energy for no particular reason? Right? There is a reason why you need energy. So you want to explain that. You have to put these explanatory variables, energy drivers, in the context of energy. And identifying those properly is the key to your data understanding. Because then you will know what you need to control your energy. So let's look at it the other way around. Let's just say natural gas consumption versus outdoor temperature now, rather than just time series. Let's just look at scatterplot data, two variables. monthly consumption on y-axis, outdoor temperature on x-axis. So I'm looking at this, I'm like, wow, there seems to be a break in usage. And that corresponds to approximately 16 degrees. So you look at your heating and ventilation setups, and you're asking your maintenance guys, what's the setting? They will tell you, oh, it's at 21 degrees Celsius, it's 25, 22 degrees Celsius. Well, in reality, once it reaches 16 degrees Celsius outdoor, you don't use any heat. The unit might be on, but your heater doesn't come on. So now this data all of a sudden becomes useful to you. Because past 16 degrees, there's no variability with temperature anymore. Now you can get a feel for, oh, let me see what else we can do about it. Again, put energy into perspective. Put it in the context of what drives the energy usage. Another way of looking at the data is do it day by day for all the months. Again, I usually like to do 3-year period. I overlay the weekends on top of it. Our ESCs have the spreadsheet. We can look at your data on your request. Why would I look at that? This is my energy usage through the weekends over the 3-year period. This is how many weekends and off days we had in those 3 years. So now all of a sudden, if I'm 24/7 operation, I expect this line to be close to that one. I'm expecting to use the same amount of energy on the weekends. But if I'm running this 16/5, and my energy here is up there, somebody's not turning equipment off. How much cheaper does it get? Turn the equipment off and get the savings. Not only that, you can quantify it. You can say how much energy you used, how much you should be using, subtract it. You have the business case and justification. Why would you turn this equipment off? That's how you should look at the data. Forget just the time series. Time series on its own won't do anything for you. Put it into perspective on energy drivers. So now we'll do a brief hands-on example again of how we collect the data, just to give you an idea of what this system here can build. And what we will do is we will have a little blower. It's going to generate the flow, and the meter is going to log the data that generates. So you can have a bit of a feel of how the system actually works like. Again, this is not be-all end-all system. It's a very simple system that Jeff built for us here. But it can be applied and multiplied in the facility all you want. You have to remember that for most of the production facilities, this is all you're going to need to collect. These are not, if you have 300 psi feeding your steam turbine, you need a little bit better than this. But if what you want to know is when your heat exchanger fails in the facility, these are the type of metering systems you can have. So Jeff is going to show us how this system works.
So we have in our data collection rig here, we have the flow meter providing data. We have the rest of the flow meter box. This has the drivers inside for the flow meter. It also has all the circuitry required to be able to output an instantaneous flow, a totalized flow, and a temperature to this display. And we also have a Z3 Controls net meter Omni that we're going to be using for logging to a remote user. In this case, it's going to be my laptop over here. The Z3 Controls speaks through a router to a web page. Web page is visible on the laptop. So we have 120 volt mains power going into the control box for the flow meter. The flow meter operates generally on 24 volt DC power. The results, the flow and the temperature from the flow meter are brought back into here. They are formatted so you can read them on this screen, and they're also formatted into a 4 to 20 milliamp analog signal that is sent to the Z3 Controls net meter Omni. That Z3 Controls net meter Omni will has the capability of logging 8 separate channels. Here we're using 2, flow and temperature. and it can log and record and retain this data and also output it through the web page via just an Ethernet connection.
So to recap, you can have a meter with a little lollipop on top, so you don't have to have a separate box. That meter will output 4 to 20 milliamp signal to the data logger that Jeff had on the laptop there. And that can be accessed from any laptop that has Internet Explorer or Chrome or anything like that running. So there is no additional software that you need. And then, of course, everybody puts stuff in the cloud today. You can do the same thing there. Jeff had there a router because that's just the setup that worked for us. But most of you will have Ethernet connections dropping off all over the place for your PLCs, for all this stuff. All it needs is an Ethernet drop. You will probably want to have different addresses for these things, but you know all that. So this doesn't require any additional infrastructure. It's a fairly simple system that captures a lot of data for you in a very simple way.